Good morning. Thanks for coming to our session today. As she noted, this is data-driven off a cliff, anti-patterns and evidence-based decision-making. I'm Tom Wilbur, and I'm a product manager at Indeed, and I help people get jobs. Indeed is the #1 job site worldwide. We serve over 180 million monthly unique users across more than 60 countries in 29 languages. The primary place that job seekers start on Indeed is here, the search experience. It's pretty simple. You put a couple keywords in the what box, followed by a location in the where box, click Find Jobs, and you get a ranked list of results. This solution is proudly built in Austin, Texas. Indeed is headquartered there in the capital of the Lone Star State, and that's the location of our largest engineering office. We also have engineering offices around the world in Tokyo, Seattle, San Francisco, and Hyderabad. So we have tons of smart engineers and product teams working around the clock to make a better Indeed. And we have tons of ideas. We have tons of bad ideas. I mean, occasionally we do have good ideas, but it's hard to tell the difference. What really matters is what helps people get jobs. The only reliable way we've found is just to see what works. So, at Indeed, we set up experiments. We run A/B tests on our site where users are randomly assigned to different experiences. We collect results. We observe those users' behavior. Our log repo system adds about 6 terabytes of new information every day. And we use that data to decide what to do, to see which features and capabilities help people get jobs and which don't. We've used data to make good decisions. But data is not a panacea. We know because we've also used data to make bad decisions. Because the truth is, science is hard. For example, one serious challenge is that just the very act of running an experiment can ruin an experiment. Let me tell you a quick story. There was a famous experiment conducted in the late 1920s at an electronics factory outside of Chicago, Illinois, called the Hawthorne Works. The factory managers wanted to improve worker productivity, so they decided to try some changes and modify the worker environment to see what it did to productivity. They started by changing the lighting, sometimes a little brighter, sometimes dimmer. Then they tried the temperature, sometimes warmer, colder. They moved brakes around. They changed the length of brakes. And initially, they were excited because their early experiments resulted in improvements in worker productivity. When they made the lights brighter, productivity went up. When they made the lights dimmer, productivity went up. Warmer, up. Colder, up. Shorter brakes, longer brakes. It seemed that everything they tried actually improved worker productivity. And what's worse, none of these effects lasted. They were all temporary, and after a short while, they went right back to their baseline. Ultimately, the conclusion of the researchers was that the very fact of changing the conditions, measuring the results, and running this test affected the workers' behavior. It wasn't what they tested, it was that they tested. This effect is now known as, after the factory, the Hawthorne Effect. And those of us that optimize websites and run A/B tests know this one well. We often sit around and talk and look at a promising result, and we say, but will it last? But is it real, or is it just the Hawthorne Effect? Science is hard. And if that wasn't enough, statistics are hard. There are plenty of ways in which an analysis can produce surprising, if not contradictory, results. For example, consider Anscombe's quartet. In 1973, a statistician described a set of 4 collections of 11 points, shown here in these charts. Each of these collections of points has the same basic statistical characteristics. They have the same mean. They have the same variance. And as shown by the blue line, they even have the same regression. What we learn from this is that a simple statistical calculation cannot tell you everything you need to understand your data, especially when there are outliers. Another similar pitfall is Simpsons Paradox. You may have heard of this. This is where a statistician went back in time with his toaster and accidentally changed the future. He tried to fix it, but every time he tried to fix it, it kept getting worse. Then there were no donuts, the people had lizard tongues, and that is a terrible way to make evidence-based decisions. Wait, I'm sorry. That's Homer Simpson's paradox. Sorry, Edwin Simpson's paradox described where you have groups of data that show one story, but when you combine them, they can actually show a completely different story. Here on this chart, you see that both the blue and the red dots show a positive trend. But when you combine all the data together, you would actually get a negative trend, the dashed black line. Imagine if your desktop conversion was going up and your mobile conversion was going up, but your overall conversion was going down. Now what do? What's right? Usually this situation, the smaller groups are the more accurate interpretation. But what this really tells you is you don't understand the relationships in your data enough to make decisions, because statistics are hard. And using data well is more than just statistics. You can have good statistics in math, combine that with a really bad idea, and you may find yourself with a very unfortunate and regrettable outcome. So bad practices can undermine even good math. And frankly, you don't need me to teach you how to be bad at math. But today, I'm going to teach you how to be bad at everything else. On top of the inherent challenges of science and statistics and bad ideas, we're going to share with you powerful techniques of how to make data-driven decisions the wrong way. So who's ready to do it wrong? All right, let's get started. Anti-lesson number 1, be impatient. One of the best ways to be bad at evidence-based decision-making is to be impatient. A p-value is the standard measure of statistical significance. It describes the probability that the observed results can occur even when the null hypothesis is true. Or more informally and nearly correctly, it tells us what the chance is that the result we see is not just random chance. For a successful A/B test, we want to see positive results with a p-value below some threshold, typically 5% or 0.05. But the calculation of p-value is just one measurement, and it's only at the time, represents a test at the time of what's happening with your experiment. It doesn't tell you whether or not the whole experiment is a good idea. So if you check your results on Monday, that's only one measurement that tells you how the test is doing on Monday. And then if you check the tests on Tuesday, that's just another measurement. And while you're doing that, your data scientist is muttering, saying that you should stop looking and just wait until we get the necessary sample size that she had computed at the beginning of this test. But your boss is asking, hey, that test, is it significant yet? Do we have something to do? What should we do about that test? This is really frustrating. But there's a better way. Do you have the result you want? Was it on that test that you already knew was a good idea? Are the results already positive after only 2 days? And when you checked the p-value on your phone while you were standing in line at the Starbucks, had it just dipped below 0.05? Declare victory. Turn off the test. Roll it to 100%. Don't waste your valuable time with all that statistical nonsense about regression to the mean and false positives. You have better things to do. But you need to move quickly, because p-values and results can change fast. That test that looks really good in the Starbucks might actually end up being bad and insignificant by the time you get back to the office. So that's an example of how a great technique of being impatient can lead you to make great, terrible data-driven decisions. And how terrible are those decisions, by the way? Martin Goodson wrote a really great article about this that showed that if you do a check for significance every day and stop tests as soon as they show significance, 80% of those winning tests that you loved and you rolled to production are likely false positives. Not just that they're neutral, they could actually be negative. And that's really dangerous. But back to our anti-lessons. Anti-lesson number 2, sampling is easy. I mean, it's hard and time-consuming to make sure that you've got representative users in your A/B tests. Let me illustrate this with a story that I call Beware the Ides of March, and you'll see how well this one worked out for me. At my last job, we were building a used car experience where we were trying to match used car shoppers up with dealership inventory. We had observed that shoppers who specify price, mileage, or year do better. They're more likely to find inventory that's of interest to them. So we had a hypothesis. Could we nudge shoppers to specify price, mileage, and year when they otherwise weren't and improve conversion? Our designers thought about it. We came up with a couple approaches. One, we'll take those facets on the search left rail and we'll push them up so that price and mileage and year are much more prominent, easier to find. Another, we'll interrupt the user's task. We'll show a tooltip that says, what's your budget? Tell me your price range. We ran this test, and the winner was the tooltip nudge. We saw a 3% lift in unique conversion with a p-value of 0.04. So we decided to roll this out. We turned off the test, rolled it out to 100%, and the effect didn't look the way we expected it to. It actually looked bigger. This confused us. It startled us, so we decided to dig in more. What we came to learn was that we had made a technical shortcut in our test assignment code. This was in the summer of 2009, and Internet Explorer had about a 60% US browser market share. My company, like many others, was getting sick and tired of trying to support IE6 when IE8 was already out. And IE6 was the browser that PC World called the least secure piece of software on the planet. So to work around a problem with allocating IE6 users to assignments, we just punted. We just didn't assign them. The users on the oldest browsers just got ignored. This turned out to be 20% of users. And even worse, that 20% was not the same as the remaining 80%. Users on older browsers, on older technology, shop differently for cars than users on newer technology. They're more price sensitive. And in fact, they're more likely to be positively affected by a nudge towards searching with price. We missampled our population. We went through all that effort to run a test and do an analysis, but that technical shortcut we took meant that we didn't measure our results accurately. We made an ill-informed decision because we thought sampling was easy. And this brings us to the third way I can show you how to make data-driven decisions terribly, and that's look at only one metric. Because if there's one thing we know in life, it's that if a little bit is good, a lot is great. Anything worth doing is worth overdoing. I mean, there isn't a possible downside to that, is there? So the first story I want to share about looking at only one metric is called Indeed Has a Heart, and it's about a test we ran in our mobile app. In our mobile app, job seekers have the ability to save a job. We decided to test the iconography of that feature, replacing a star with a heart. We did this on our details page. We did this on our search results page. We ran the test. We looked at the results. And were hearts better than stars? You bet they were. We observed a 16% increase in saves on the search results page. This was great. Everybody loves hearts now. So we rolled out our test to 100%, and we said, but why stop there? The obvious thing to do is to put hearts everywhere. So we've hacked into the Gaylord's website, and we've replaced their ratings with hearts, because hearts are awesome. We've passed on our results to Google, and in the next version of Gmail, the starred folder was going to be replaced by the hearted folder, so you can mark the emails that you like with a heart. And back in Texas, we've put a bill in front of the governor, and soon we're going to be living and working in the lone heart state. It's going to be great. Yeah, not so fast. Changing the stars to hearts improved the one metric we were looking at, usage of the Save This Job feature. But did hearts help people get jobs? Sadly, no. There was no discernible effect on job seeker success. When we looked at long-term job seeker behavior, at our primary metrics of clicks and applies and hires, there was no evidence that hearts made a difference, which is unfortunate, because that's our goal, not to help people heart jobs. What we had done was focus only on one metric. But if you really want to do evidence-based decision-making wrong, you should look at only one metric in situations beyond your A/B tests. This anti-lesson can apply across your whole company. For example, at Indeed, we have a talented client services organization that engages with our employers to help them understand the value they're getting with Indeed. Improving existing revenue is clearly important, and we had a hypothesis that if we had a team focused only on that, we could be more successful. So we formed a dedicated upsell team in client services, and we measured their results on a dashboard. What we looked for was that when there was an upsell contact from a rep to a customer, and then subsequently the customer's spend increased, we credited that increase on the dashboard to the rep. And this was also tied to a bonus program. So we started off, and the dashboard says it's working. Reported upsells on the dashboard show lots of wins. We see tens of thousands of dollars of increases in revenue. This is great, until someone asked, why isn't revenue moving? Overall revenue for the total population of accounts was flat. When we stepped back, we realized not every contact between a rep and a customer results in an increase in spend, of course. Sometimes you have that positive account we were logging, sometimes it's neutral, and sometimes it's negative, and spend goes down. Our naive dashboard only looked at one metric, the positive outcome, and so it didn't actually represent reality. And furthermore, when you're showing people a metric that rates their behavior, what you measure is what you motivate. The reps reported that they were actually less interested in calling an employer who had said they might want to reduce their budget. So all the incentives were pointed at only getting an increase, and nothing else mattered. This was not what we wanted, so we made a change. We modified the dashboard to include all the outcomes, restarted our team working, and after that one change, we saw more diverse interactions and much better results. The revenue of the upsell team went up by over 200%, and we decided to continue that experiment and grow the team. So that was 2 examples about how looking at only one metric, especially when it's an easily computed metric or the first one that you thought of when you were planning this out, is a great way to do evidence-based decision-making wrong. But this anti-lesson has a flip side too. Because another secret to making bad data-driven decisions is to look at all the metrics. For this anti-lesson, we'll return to Indeed's mobile app. We were looking at the mobile apps of other companies, and we noticed a growing adoption of a particular way to show off menus, with that 3-dashed icon you see on the upper left, what became popularly known as the hamburger icon. Well, one of our product managers got very excited about this and stole the idea. So we ended up with a hamburger menu in our Indeed mobile app, and we ran a test to see if it made it better. Because it was better for them, but we need to see if it's better for us. Let's look at the results. Job applications are up. That's great. Job clicks were down. That's not good. Recommended job traffic is up. Job views, new resumes are up, but return visits are down. Logins were up, but revenue is down. And this just kept going on. What we realized was we didn't really know what we wanted. We didn't start our test with a goal in mind for what the hamburger menu was supposed to do inside Indeed's mobile app. So when the metrics came back with conflicting answers, we didn't know if the change was good. We couldn't know if the change was good. There was too much noise from too many metrics. We actually ended up leaving this test running for a really long time, hoping that more data would make the right decision obvious. It didn't. We ended up with lots of discussions and email threads and meetings about, no, seriously, we have to decide what to do about the hamburger test now. In the end, we turned it off, and there's no hamburger menu in the Indeed mobile app today. In this case, by not starting with a clear goal and by trying to look at all the metrics to make our decision, we spent a lot of time and energy, and in the end, we failed to make an evidence-based decision. Now, I'd like to introduce my colleague, Ketan, who will teach us about even more exciting ways to make bad decisions. Ketan?
Thank you, Tom. So my name is Ketan. I'm an engineering manager at Indeed. And like Tom, I help people get jobs. Along the way, I help people make bad decisions, and I'm going to help you make bad decisions too. A great way to make bad decisions is to be sloppy with your analysis. When we engineer features, we do it rigorously. We have numerous tools and processes for ensuring that our features are built well and they're built correctly. We use specification from product managers and product owners. We check our code into source control. We do code review, both manual and automatic. We write automated tests. We have manual QA, people who walk through the feature to make sure it works correctly. After we deploy, we use metrics and monitors to ensure that the feature is functioning correctly. With analysis, whatever. Bad analysis won't take down Indeed.com. There are 200 million job seekers around the world who don't care at all about our sales projections. So we don't try as hard with analysis code. In fact, we often don't even think of it as code at all. That means we don't have a specification. It means we don't check things into source control. We don't do code review. We don't use those other processes and tools that work so well for us with our features to engineer them correctly and carefully. This bit us in a story I call Dubliners. Indeed reports on economic trends. We have access to proprietary data from job search activity and from employer activity, and we combine that with publicly available data to see into trends in the marketplace. For example, labor mobility. One of the things we observed was that many South Carolinians wanted to move to Dublin. Which Dublin is this? Well, it turns out there are many Dublins in the United States. Just north of South Carolina, in North Carolina, there's Dublin. Across the other border, there's a Dublin, Georgia, there's a Dublin, Ohio, there's even a Dublin, Texas, which is the home of Dr. Pepper. Maybe that's where they wanted to move. That's the one Dublin they meant. Nope, the other one, the one in Ireland. We were relying on out-of-date data for our research. We happened to pick upon a location that had IP blocks that got moved to London, England. We were using a well-known mapping service, but we weren't using the most up-to-date data. So when we reverse mapped this job seeker activity, we incorrectly thought that all these Londoners who were looking for jobs in Ireland, who were trying to Brexit, they were in South Carolina. And we had this intriguing story of people from the deep south wanting to move to the Emerald Isle. Whoops. There are worse things that can happen. This was a minor detail in a minor publication that we put out, and we caught it before we published it. In the story of growth and debt, the consequences were much more serious. Growth in a Time of Debt was a major publication by the prestigious economists Carmen Reinhart and Kenneth Rogoff in 2010. The key finding of this research was that public debt, once it exceeded 90% of GDP, led to dramatically slower economic growth. This was a big, big finding. There were governments that made policy based on this. Tax policy, spending policy, and these decisions affected tens of millions, possibly even hundreds of millions of people. There's only one thing wrong with this, and that was the Excel spreadsheet that they used. They wanted to compute averages across all of these countries, which are represented, you might see, in rows 30 through 49. But when they entered the formula into the spreadsheet, they averaged only up to cell L44. There were 5 cells from L45 to L49 that were left out of this computation. Researchers a couple of years later, trying to reproduce this result, were unable to, and they got the original Excel spreadsheet from Reinhart and Rogoff. Fixing the error in the spreadsheet eliminated the effect. Now, these might have been good policy decisions, they might have been bad policy decisions, but the research that was under it, that justified these decisions, was completely flawed and mistaken. This kind of mutation can happen elsewhere, for example, genetically. It was recently reported that 20% of genetics papers have Excel errors. And this happens in a very interesting way. Sept2 to a geneticist is septin2. It refers to a particular sequence of DNA that code for the construction of a protein. Sept 2 in Excel is the number 42,615. That's a magic number that denotes September 2nd, 2016. So anything in that spreadsheet that processed Sept 2 would not treat it as that 5-character alphanumeric sequence. Instead, it would treat it as this as this numeric value. What would be the result on the research results? Not good, I can tell you that. So does your company use spreadsheets? Is there some niche in your company where they use this obscure, highly specialized tool to run analyses and make decisions? I imagine there is. Well, how do you know they're correct? How do you know that these spreadsheets are constructed properly, that they're interpreting the data properly? We had a problem with underspending advertisers. Employer budgets ran out before the end of the day. That meant no evening job seekers saw the jobs that they were advertising. We thought, this is a real missed opportunity. How big is this missed opportunity? We started with a prototype built on a spreadsheet to analyze this. And we were constructing a product that would email employers. And we would say, well, hey, you got 1,260 clicks yesterday, but your daily budget ran out at 8 p.m. If you funded your budget through the whole day, you'd get another 260 clicks, which is a 20% improvement. That seems like a win-win situation. The employers get more applicants for their jobs, and Indeed gets more revenue. This wasn't an implementation flaw, though. This was a specification flaw. Underlying this report was this assumption, that traffic was uniform throughout the day. Obviously, that's ludicrous. The assumption then led to the conclusion that we would increase clicks by 20%. But reality looks a lot more like this. And so the actual lift would only be 8%. Still a benefit, but we were overpromising something we couldn't deliver. Our naive analysis led to a bad recommendation because we lacked rigor in how we conducted this analysis. Another way to really screw things up is to only look for expected outcomes. In the early days of Indeed, we had a problem. There were 0 results pages from misspelled locations. Job seekers would try to type in the name of a place and sometimes would forget that Minneapolis has 2 N's in it. We were unable to match this to a location in our database, and so we said, sorry, there are no jobs. So we didn't help people get jobs in that situation. We adopted a simple strategy on our homepage to try to defeat this, something that's been adopted by many companies before and since. We did autocomplete. The job seeker would type in a few characters of their location, and then we would match that against known locations in our database. In this case, Minneapolis, St. Paul, Minnesota. The job seeker would select the matching location, it would submit the form, and then they would see their search results. Pretty straightforward. Our goals with this were fewer 0 results pages and more job clicks. And that's exactly what we saw. 0 results pages went down by 2.7%, and job clicks went up by 8%. So this was a pretty successful test where we expected it to. And as a bonus, as it turned out, revenue went up by 1,410%. Very nice. Great success. This was an excellent A/B test, wins all around. What the crap, dude? How did ad revenue go up by 1,410%? This was an unexpected result. Let's look at this homepage where we put the location autocomplete. There's no ad here. This is not a revenue-generating page. Like me, as an engineering manager, this page is actually a cost center. It provides no valuable benefit whatsoever. The revenue comes from the next page, the search results page. That's where the ads are. And we would expect a modest improvement in this because we were seeing fewer 0 results pages. But 1,410% seems ludicrous. We went back and we examined our implementation of this feature. Job seeker types in a few characters. We show completions. They select one, and we submit the form. But the job seeker didn't necessarily know that we were submitting the form when they made the selection. So they would move the cursor to the blue Find Jobs button and click on that. Now, one of the things that we're really proud of at Indeed is that we have a really fast search. We spend a lot of time optimizing that search to provide responses very quickly and to have a very quick user experience. We think speed is a feature, and so we work really hard so that by the time in many cases, the job seeker got to the blue Find Jobs button and clicked on it, they weren't on that page anymore. They were on this page. And their click landed on the sponsored link. That gave us a 1,400% boost in revenue, but it was not what the job seeker wanted. And it didn't help them get jobs. So the fix was pretty simple. When they selected the completion, we would fill it in, but we wouldn't submit the form. The downside was we had to add another step to the job seeker's flow. But as it turned out, many of them were expecting that flow anyway, and at least this way, we didn't contradict the user experience. Ad revenue after the fix was much more reasonable, much more in line with what you'd expect from a feature like this. The problem that we had was our treatment was on the homepage, and if we only looked at that treatment, we would have seen the outcome we expected in the place we expected. We actually got lucky that somebody noticed this revenue increase. If they hadn't, we would have nicely made a bunch of money, but we would have done that by confounding user expectations and sending them to something they didn't want. Another great way to screw things up is to look at only metrics and not stories. Now, I help people get jobs. That's what my shirt says. That's what Tom's shirt says. How do I know if people get jobs? The thing is, Indeed sends people to other places. Our job is to send people to some kind of ATS, some kind of hiring site. We are not plugged in to the onboarding and hiring processes. So when somebody actually starts a job, we don't know. I need employers to tell me when they've hired somebody. Now, Indeed does have a product that's useful for employers. It helps them post jobs and receive applicants. They can process these applicants through the hiring process, and then they can mark this applicant as hired. Indeed started as an aggregator, but this product has been a big growth area for us, both in terms of revenue and in terms of jobs and in terms of hires. So it's been a great success. In fact, it's been such a great success that one employer hired 4,500 people in 45 minutes. That, my friends, is the power of Indeed. Indeed cures unemployment. So there's a reason you didn't see this headline, because nope, that's not what happened. Accurate recording of outcomes helps us. It helps me know as an engineering manager, it helps Tom know as a product manager whether Indeed is on track at fulfilling its mission. It doesn't help employers. Detailed annotation of data in our system does nothing for them. So they don't care about using the product right, according to our idea of what right is. Imagine you're an employer, you posted a job, you got many applicants. You hired one person for the job, but then you've got all of these applicants showing up every time you log into Indeed. You just want them to go away. So this employer found that the most expeditious way to make all of these go away was to just mark them all as hired. Boom, they're gone. There is no user story here because the user simply doesn't care. The thing that we wanted as Indeed to derive from this experience does not line up with the user story. The user wants to hire people and then move on. We had the right metrics, but we had the wrong story, and so we concluded the wrong thing because we didn't understand how the user wanted to use our product. Now, there's a corollary to this, a part deux, if you would, and that's favoring story over metrics. The thing is, stories are seductive. Storytelling is one of the most ancient of art forms. It's vivid, it's compelling. The thing is, even incorrect stories are seductive. And that brings us to the story of your taste buds. We've all seen this map. We know that in the backs of our tongues, we taste bitter flavors. On the sides of our tongues, we taste sour flavors. Towards the front, salty flavors. And the very tip of our tongue tastes sweet flavors, which is really handy for lollipops. This map is also totally wrong. Now, the interesting part of this is not that the map is totally wrong. The interesting part of this map is that it's totally wrong, and every bite you eat proves that it's wrong. When you have breakfast, you taste salty all over your tongue. You taste sweet all over your tongue. When you have second breakfast, the same thing happens. Lunch, dinner, dessert, second dessert, midnight snack, Every time you taste something, you know that it's wrong. And yet, people still believe in the taste bud map. I'm not going to ask anybody here who believed in the taste bud map. Don't want to embarrass you. But these stories are so seductive, they stick in our head and get lodged there, even if in the most visceral of experiences, eating, we are confronted with evidence constantly, and we don't realize that our understanding is wrong. There's a more directly applicable story, and that has to do with our job alerts. Indeed sends emails to job seekers who have signed up for job alerts. These contain new results that match jobs of interest to this job seeker. This saves them the trouble of coming to Indeed's website every day, and it's another way of getting them to get a chance at getting a job. Now, the success for emails is well understood. Email's been around for a long time. As a product, we know exactly what it means for an email product to be successful. If you get new subscriptions, that's good. If job seekers open your emails, that's good. When they click on stuff in the email, that's good. Unsubscriptions are bad. So when you're iterating on an email product, you want the green things to get better, and you want the red thing to stop happening. But the thing is, my t-shirt doesn't say, I help people get emails. My t-shirt says, I help people get jobs. So let's look at what job seeker looks like. Step 1, search for jobs. Go to Indeed.com, type in some keywords, type in a location, and see what's there. These are interesting. I would like them emailed to me every day. I'm going to sign up for alerts. I get alerts every day, I read through them, and I click on some of the jobs in there. Some of those jobs are especially interesting, so I apply to some jobs. And then, hooray, we have a happy outcome. I got a job. Excellent. Indeed succeed. We achieved our mission. There's a step 6. Unsubscribe from emails. The thing is, people with new jobs, they don't need job alerts. Indeed has been successful. We helped them get a job, and now we're no longer necessary. The standard story for email fails here. We actually want job seekers to go away from our email product because that probably means they got a job. If we were to optimize for hiring, we might see some of those metrics that we thought were good go down. We might see the metric that we thought was bad go up, but it reflects job seeker success. Conversely, if we optimized for those metrics, we might actually hinder job seeker success because the story that we had didn't match reality. I want to get back to the story that Tom told you of light and dark. So he mentioned how environmental changes were observed to increase productivity in workers at the Hawthorne works, including changing the brightness. This is a persuasive story. It fits with our understanding of the mind-numbing nature of repetitive work and the effects of environment on stimulating the mind. But the original story was flawed. There were a couple of economists a few years back who went and researched it, one of which was the co-author of Freakonomics. They took the original data and they went through it again, and their analysis found that the variance in productivity could be fully accounted for by the fact that the lighting changes were made on Sundays and were therefore followed by Mondays when workers' productivity was refreshed by a day off. In other words, they were not observing positive effects from environment changes. They were observing positive effects from a day off. And yet, for 100 years, people have believed in the Hawthorne effect based on a faulty analysis of data. The story made sense, so we didn't question it. We con people with stories, and we con ourselves with stories. And that leads to the last and most important of the anti-lessons. Believe in yourself. This is a great way to make mistakes. Now, believing in yourself can be good. My startup will succeed. Startups have been the source of many, many innovations and tremendous wealth. For me, they've also been the source of 3 layoffs. But we need people to believe in order to generate that wealth and that innovation. Often, however, it's bad to believe in yourself. I'd never fall for a scam like that. Thinking something like that, saying something like that, almost certainly increases your chances of falling for a scam like that. I knew it all along. This is the self-serving lie we tell ourselves to guard our egos, but it also inhibits learning. I'm too smart to make that mistake. I'm sure some of you thought that when Tom and I were telling you about the mistakes we've made, which admittedly, some of them were pretty dumb. But here's the thing. Every story of mistakes is deceptive. The stories that Tom told you, the stories that I told you, they have a deception at the heart of them. And it's in how they're presented. In each of these mistakes, somebody noticed that something was wrong. Somebody followed up, somebody investigated, somebody understood the mistake. And then Tom and I came up with a neatly packaged story to present to you. And then you, in the audience, you knew there was a catch when you came to this talk. You knew every single time we launched into a story that there was something in there that wasn't what it seemed. That primed you to see the mistakes and made them seem a lot more obvious than they actually are. We tell stories with 20/20 hindsight. This happened, and then this happened, and this happened. And it gives a clarity to the mistake that we simply don't have when they're happening. When we live the story, we live in a fog. You won't think you're making a mistake when you are actually making a mistake. That's why so many of the mistakes happen. If you search your past for mistakes, in particular, perhaps you should search your email outbox for mistakes. Painful, embarrassing mistakes. You'll probably find some. If you don't find any, you're exceptional. Or maybe you just think you are. There are really only two possibilities. Either you're making mistakes that you find, or you're making mistakes that you don't find. How do you defend against mistakes? Well, the first step is admitting you have a problem. Although that's also deceptive, because you don't have a problem. You have lots of problems. Tom and I are telling you about a handful of examples of problems you have. In addition, there are 174 cognitive biases, at least. And there are many other classes of mistakes that you can make. All of these are going to infect your decision making. Data can help you make better decisions. Absolutely. It's a great tool for making better decisions. Or a great tool for more confidently making bad decisions. Data can't make you a better decision maker. That comes down to your mentality and your practices. If you take a good data and a bad decision maker, you're going to get bad decision. Our anti-lessons teach you how to use data badly. Do the opposite to do better. Lesson 1, be patient. Understand that it takes time to collect a valid data set. Do not open your Schrodinger's cat box until Christmas. Just have to wait. Lesson 2, sampling is hard. There are many, many ways bias can sneak into your sample and make it not representative of the overall population that you're targeting. Lesson 3, focus on a few carefully chosen metrics. If you only look at one metric, you're blinded to other effects of what you're doing that could have a negative impact on other parts of your business. If you look at too many metrics, that could lead to confusion and analysis paralysis. Lesson 4, be rigorous with your analysis. We're rigorous with the features we build and deploy, but we're making very important decisions based on the analyses we do. We need to make sure that those analyses are conducted as rigorously as the features they're based on. Lesson 5, watch out for side effects. Every change we make, every feature we implement, has a desired primary effect. That's why we're doing it. But you have to build systems and processes that alert you when side effects occur, because that side effect may be more costly than the primary effect. Lesson 6, use metrics and stories. Metrics help you know what's happening, but they don't help you understand it. They don't help you make sense of it. You need stories to do that. But the thing about stories is that they need metrics. Otherwise, they can become disconnected from reality. You need to use the two together to understand what's happening and to make sense of it. And then finally, plan for fallibility. We're all human. We all have errors in judgment. We all have errors in knowledge. Plan for fallibility, build processes around it so that you can catch your mistakes instead of blithely moving on into the future, having made a mistake and not realizing it until its consequences have snowballed into something catastrophic. I hope you learn from our mistakes, and I hope you're better prepared for your own. Thank you. So we're going to switch microphones so that we can get questions. if you have a question, wave a hand and or go up to the microphone, and we'd be happy to answer it. Thank you for getting the ball rolling.
Well, it helps that I help pick the talks, so I already have questions that I want to ask you people. So I guess the one thing I wanted to ask you, I'm really glad you guys came and sort of give a talk on like, here's all these mistakes that we make, because we all make lots of mistakes, as you noted. I am sort of curious about fallout, or, you know, I guess there's that whole like blame culture thing of like, hey, we just realized we did something that was really stupid, and now we got to go tell somebody that there was actually sort of a negative side effect because of these mistakes. Hopefully now you have a culture where people are open and honest about that, I assume, or you wouldn't be able to give this talk. Has it been that way for a long time, or what struggles have you had with that, especially as you're seeing things come up in data that you can't really run away from? So,
I think, yes, we avoid a blame culture because you have to accept that the people that you have in your company are humans, well-intentioned, knowledgeable, experienced, but not perfect. And the null hypothesis of that is maybe that people can be perfect, and they can't. And that's why it comes to, you know, systems around the people. And I think probably the best system is a culture that accepts that people make mistakes and accepts that, you know, the responsible thing to do is to say, hey, I screwed up. As a software engineer, I've taken Indeed.com down a few times. I can tell you in great detail, actually, how I did it, or I've broken features on Indeed.com a few times. Maybe by analogy, it's like machine failures, right? A lot of what we talk about from a technical architecture aspect is your hard drive is going to fail, your CPU is going to overheat, that machine's power supply is going to get blown out. Mistakes are going to happen. If you build a system that can only function if all the components work perfectly, you're going to build a system that will fail. It's brittle. And I think there's something similar for a company and culture. If your company and culture require people to be perfect to succeed, your company is going to fail. You have to account for the fact that well-intentioned, knowledgeable people will make mistakes of judgment. And the question is not how do you prevent those mistakes, although that's a useful question. The question is, how do you respond to them? Does your organization become smarter? From the admittedly foolish examples that we've described, I hope that we as a company have become smarter. I hope you in the audience have become a little bit smarter. And that's really the best outcome you can hope for. Perfection is stasis, but mistakes that lead to learning are continuous improvement. Does that answer the question?
So hi, a lot of these lessons seem like lessons learned over time. With this knowledge in hand, how do you train up people to be sensitive to them going forward?
Okay, that's a good question. I can address part of it, and I think maybe Tom can address part of it from the product management side. One of the things that I was going to talk about that we cut due to time is that we conduct peer review in a sense of how we analyze our features. So we have analytic systems that allow for very easy permalinking. So you can link to a dynamic data set. When we use Jira as our issue tracker, and so in every feature that we roll out, somebody, often the product manager, but potentially somebody else, summarizes the results of the feature. And these are all permalinked. So if I put something in and say, hey, it looks like clicks are up, Tom can see the analysis that I ran, and then he can iterate on it. So he can say, okay, well, is that true in Brazil? Is that true in India? What about Japan? What if I differentiate between iOS and Android? And so he can tease out relationships in the data. Not only can he review what I did to see if it's correct, he can improve on it. And so I think that fosters a culture that's focused on exchanging facts and analyses rather than opinions and pointing fingers and blaming things. Another thing we do is we have tools around metrics that have basically a standard template for each product. So the thing about each feature is that each feature is a unique thing, right? Each feature you do in a product is a unique thing. It's different from all the features you've done before. But within a product, the success metrics are going to be relatively constant. At Indeed in the job search product, the analyses rest on, do job seekers click on jobs? Is the site fast? Does anybody get hired? It's a relatively constant set of metrics that apply no matter what the feature is. The features are going to be unique, but each analysis is going to be basically the same, and building tools around that prevent us from intentionally or accidentally cherry-picking results and focusing on something like saves are up, but the rest of the metrics don't move at all.
Yeah, and I'd agree with Ketan's comment there. And one of the other ways that we help, especially to inculcate the type of behavior for new employees, is to both bake it into the technology, but also bake it into the company, into the way our organization and the way our processes work. On the product side, a core piece of performance evaluations is not just necessarily, are you always right? Product managers are actually graded and scored in our performance evaluation system on, do they test things in a simple manner? Do they try to test things quickly? Do they learn from their mistakes? And then another way we sort of make that apparent is to model this behavior of talking about failures when we do a quarterly meeting at Indeed and we all get together to say, hey, let's talk about the things that happened last quarter. We review successes and failures. So we put up some things that are say, we tried this thing out and look at these great metrics that worked really well. And the story I told about the hamburger menu was actually featured in a company presentation, talking about we tried to do this and we didn't really know what we were trying to do and we wasted a bunch of time and we're going to do better next time. And don't get me wrong, going through those presentations and getting up and standing and saying, I screwed up is still hard. It's a little, it's counter to our natural ego things. But if you build it in and you model it, and the new employees come in, and in every quarterly meeting, somebody is standing up saying, well, here's 6 tests we ran, they didn't work at all. Then I think it helps create that environment where failure is seen as learning and mistakes are seen as improvement.
Thank you.
I guess more on that point. How did the company get that in its DNA? One of the reasons I was kind of attracted to come to this particular talk was because you don't really get a lot of conference talks about everything my company screwed up. So, how did you get imbued with that?
Well, there also might be a survivor bias, which is that a lot of the companies that screw up don't end up lasting long enough to come to a conference. So part of it is that Indeed has been successful, so we have the ability to also talk about our mistakes, and perhaps it's more entertaining than coming up here and telling you how wonderful we are. As for the history of how it became, I might see if Ketan can help since he's been around longer than I have.
I think one thing that's helped is that I've been there a long time and I've screwed up a lot of times. So if we didn't have some mechanism for making me suck less, there might have been some more serious consequences. We early in our history, when we were a small number of employees, I think we benefited from having some very strong-minded people who were very empirical in their focus. And so some of the things that other people have talked about in having relatively little ego in being attached to your ideas, those were set in relatively early, and it became kind of a snowball effect. I don't think I could give you any insight or wisdom on how to retrofit this mentality into a culture, but fundamentally it comes down to we are trying to achieve an outcome in the world. We're not trying to feel good about ourselves. We want to feel good about ourselves, but that's a nice side effect. We aim to achieve a significant outcome in the world. Fundamentally, it's company earns revenue and I help people get jobs. You can tell yourself, right, that I'm successful because I like this feature. But there's, in a sense, it's kind of the just do it thing. It's just look at whether you actually were successful. Close the loop. You entered some endeavor with an end in mind. Did you actually achieve that end? If you're really serious about achieving that end, you'll assess, analyze, and modify your approach. If you're not serious about it, I actually don't know how to retrofit it. We just benefited from some really hard-nosed empirical people who attracted similarly hard-nosed empirical people.
Thanks. Sorry, I'm 15 again. Thank you.
I have a question too. You talk about cause and effect and analyzing data in a way that you can make decisions, and in between those two comes concluding something. And one of the things you mentioned is that for us, users unsubscribing from our emails is a good thing, but that can also be a bad thing. Like, there are several possible conclusions one can come to. Is there any way you weigh those possibilities before you come to a decision?
You're completely right. Unsubscribing, I oversimplified. So it could be that somebody unsubscribes because they got a job. It could also be they unsubscribe because Indeed is not helping me. These jobs are irrelevant, or these jobs seem relevant, but nobody is responding. I don't have an easy, clean answer for that, because it relies on us being able to understand the intent of a user, but it's understanding the intent of a user who's disengaging. We do get some positive signal because when they unsubscribe, we show them a form that asks them why. But this is a survey-based methodology, and if a job seeker is done with Indeed, they're probably not going to submit a form and tell it to us. So we clearly have a biased sample there. I don't have a great answer, but Tom's the product manager.
Well, I was going to talk about the brilliant feature where we actually survey those outgoing things, but then Ketan undercut my example. No, we believe that is the right thing to do, which is to ask the user, did you get a job? And we may not get a good answer. We may not get a consistent answer that, no, I hated it. But certainly given the enthusiasm and emotional benefit of when someone does get a job, we believe that we get a pretty good response, at least on the positive side. So you're not comparing the positive and negative, but if you compare positive to total set, you can get a little bit of insight into that. I'd also encourage you, there's a really good article I read, and I don't know the reference offhand. Dating sites, OkCupid and similar, have a very similar problem. And they talk about what they refer to as good churn, which is your customers go away, but then they come back because they're dating again. And how do you deal with the fact that when people stop responding, that might mean that you got them in a relationship, or maybe they're no longer interested. So there's some other companies out there that have that similar problem where a traditional way of evaluating something is a little problematic.
Although, and it's funny, you didn't plug your product here, but we are trying to work further upstream. I said we don't necessarily know when somebody got hired. We're doing more and more work to try to integrate with these systems. Tom is the product manager for that, where we try to understand when somebody got hired. We also have some indirect signals. So, a metric for a long time was clicks, but we also now can understand when somebody applied to a job. So if somebody applied to a bunch of jobs and then they unsubscribed versus somebody who didn't apply to any jobs and then unsubscribed, there is some suggestion there that we can mine. We also can track responses from employers in some cases. So if there's a positive sentiment in an email sent from an employer to a job seeker, we can mine some of that data, although it's early stages for us, so I can't state anything conclusively about that. But this is, the problem you described. It is an important gap in our understanding of what we do. And so we're trying to move upstream and gather more data to fill in those blanks. All right. Well, thanks, everybody. Thank you for coming. If you want to ask questions more informally, I'll linger near the front for a few more minutes. Thank you.